That's a positive. Yeah, sorry. It started out with a dash and then it turned into a positive. Okay. Hopefully this works. So, let's say I want to find the roots of 1. Roots of 1. In other words, for example, if you want to take the square root of 4, really you're looking for some number squared that would give you 4. Okay? So it's the same idea. So I'm looking for this s that when it's squared, it gives me 1, or negative 1, I'm sorry. The negative 1 is 1ei of pi plus 2a pi. So let's just apply the properties of exponents. So s squared, parentheses, raised to the 1/2 is equal to, on the right hand, I'll put a big parenthesis, 1e I pi plus 2a pi, parentheses to the 1/2. Okay, so here's what we get. We get s is equal to e, but wait a minute, that just puts all of this divided by 2. So it's going to be I times pi divided by 2 plus 2 times k times pi divided by 2. Now let's check our solutions. Hopefully this works. Okay, so let's try this. When k is 1, then s is equal to e I over 2 plus, this is a 1, so that's going to be 2 times 1, that's 2. 2 divided by 2, that's 1. So plus pi. Oh, wait, I'm going to leave this 2 pi over 2. So that's e pi, pi, 3 pi over 2. Did I do that right? Just adding the exponents? K is 1. So I put in a 1. I left the common denominators to make my life easier. So, you know, I'm sorry. This should have all been in parentheses. Times I, holy smokers. Put it this way. That's what I mean. I, there we go. I see. Okay, I. There. And let's try k's too. So k is 2. And I would have s is equal to e raised to the I, parentheses, and a pi over 2, plus, this becomes a 4 pi over 2. So 4 pi plus 1, that's 5 pi over 2. Oops, nope. Just writing the exponent, not the whole problem, is e I times 5 pi over 2. So here's my question. EI to the 3 pi over 2 is going to be what? 3 pi over 2 would put me right there. That was one of our solutions. And then e to the 5 pi, there's 3 pi's, there's 4 pi's, there's 5 pi over 2, and there's my other solution. So here's the idea, and it extends out. I'll try one more. The idea is that the roots of unity, it's called roots of unity, because when you start taking the roots of e to the I theta, all of the answers lie on this circle. And they always divide the circle evenly. So if you have 2 solutions, the circle will be divided into 2. If you have 3 solutions, the circle will be divided into 3 equal parts. 4 solutions will be divided into 4 equal parts, and so on. So whenever you're taking roots of complex numbers, the answers are somewhere evenly spaced on that circle. Let's try one more. Here we go. Let's try it. So, find the 5th root of minus 32, I. Sure, let's try that. How many answers should we have? Here, by the 5th root, there should be 5 answers. It would be like solving something squared. So in other words, a 5th root means there's some number s, and it's raised to the 5th power, is equal to minus 32i. Okay, minus 32i. Holy smokes. I always have to think about these for a moment. Minus 32i is right there. You might have thought it was a little further down than that, but it's right there. Real? Imaginary? Okay, so there's minus 32i. What's the modulus? Yeah, the modulus, remember, is a positive value. So the modulus of this is 32. E to the I, and what is our argument? Yeah, 3 pi over 2. What if I wanted to, what's another way of writing 3 pi over 2 if I didn't want to go clockwise? Or counter. Yeah, I could also write it as minus pi over 2. Let's try that. It looks a little small. So I'm going to write it as e raised to the minus I pi over 2. Okay. Now here's where you have to remember. It goes around and around. So I can get here by adding what? 2 pi. And I can add 2 pi and I'd be right back there again. And I can add 2 pi and I'd be right back there again. And it goes on forever. You can just keep adding 2 pi over and over, and you'll still be at minus 32i. So you need to remember to add, parentheses, plus 2 times pi, or 2 times, I'll write it this way this time, 2 times pi times k, meaning the number of trips around the circle that you want to take to keep ending up at the same place. Next one?
So, well, that's example. Like, you got like it wasn't changing, but take the 5th root, so why don't you keep that 12?
Yes, I'm getting there. Okay, so let's take the fifth root of this. So the fifth root says if I have s to the fifth is equal to, I'll write it out, 32 e I to the minus pi over 2 plus 2 pi times k. Now the rules of exponents behave just like you would hope. So this is the same as saying s is equal to, what's the fifth root of 32? I'll write it out. I'm gonna write it out. 32. We have to take the 1/5 of that times e I minus I over 2 plus 2 I k, and we have to take 1/5 of that exponent. I picked one that would work. What is the fifth root of 32? It's 2. Okay, so this is going to be 2 e raised to the I over, okay, this is going to be interesting, over a minus pi over 10 plus 2 pi times k over 5. So now, how many roots do we expect? 5. So all you have to do now is find, or see the 5 roots. 5 roots are k equals 1, 2, 3, 4, and finally 5. And at 5 you should be back to where you start. This last one should be put on the bottom of that. Let's try. So I'll write out a couple of them. We have k is 1. This is s. And actually, this is s to the first power. I have 2. E I minus pi over 10 plus 2 pi times 1 over 5. Oops, 5. So this is 2 e I. So notice that if I had a common denominator, it'd be 10. This is going to be a 4 pi. So 4 pi minus pi, that would be 3 pi over 10. That is my first one. And you keep on going. K is 2. This is s squared. Is 2. E. Only one more I. Raised to the minus pi over 10 plus 4 pi number over 5. But this would really be like 8/10. So I'm going to write that as 2 e I to the 9 pi over 10. Now, 8 minus 1 is 7. 7 pi over 10. Question?
Can you distribute the number on the I, weird on the left? You have negative I times 2 pi over 2 plus 2 pi k. And then on the right side, you have negative 5.
I'm sorry. Thanks. Let's fix that. That should have been I. Parentheses minus like that. Three questions.
negative there, and then go like another way around.
Oh, do minus 2 pi?
Yeah.
Yeah, you could. I've never seen that done. Usually you always go forward, positive 2 pi. It would work. It would work. Any questions? All right, so the last few minutes, I just want to talk about the test. So Wednesday is the test. We'll be over to chapter 1. It'll focus mostly on from 1.4 to 1.8. That's kind of the meat of the chapter. I'm going to, I haven't even written it yet. I'm kind of not sure exactly what I want to do. But here's what I'm going to be trying something, maybe some of you heard it. I'm going to be trying to grade it in what's called grade score. It's an electronic way of grading this thing. So like, for example, if someone forgets a half, like forgets a minus sign, I give one person an A minus for that one, and the other person, maybe they're somewhere at the bottom of the stack and I'm being frustrated and I forget about that and I give them a B, I could be like, oh wait, that person got an A minus for the same thing. So then I can just like hit go and it'll correct anyone else that made the same mistakes. And it'll allow me to comment more on your test. So that's my theory. Okay, so I'm going to be giving you your tests loose leaf with a paper clip. So when you give them to me back to me, you're going to give them to me all nice in order with a paper clip. Also, so this is just a general rule of thumb. So I think my writing is usually pretty clear. I expect the same of you. If your Z, your S, your 2, and your 5 are all the same thing, I'm going to just circle it and go just drop a grade. So if you want a good grade, and then just write well. You don't have to be like a laser printer, even though it's nice. But you do have to write legibly for me so that I can grade all these. Because after 45 of these, if you want me to grade something, and it's not on the paper but was in your head, how much credit can I give you for that? None. I can only grade what's on the paper. So when the problems say show your work, what that means is, what? Yeah, show your work. I don't know what's in here. I can only grade you based on what is here. So please show your work. I hope to be giving the test back to you on Monday. So I'm hoping that I'll be able to give you guys more feedback on the problems. It's one of these cool things. I don't know if it's going to work. But in the end, the long term is some of you have had me before. You probably realize I usually don't write a lot on tests. If you didn't, in the end, if you work a problem and you didn't understand how to do the problem, or you didn't get the grade you thought on the problem, then the burden is on you at that point to just come to me and let's go over your test. I have no problem with going over an entire test system. And many of you have come to me that have had me in other classes. We just sit down, we start with question number 1, and we write the whole solution out. So because of that, if you're wondering why you missed it, and I didn't comment enough to make it clear, then just once you've gotten over your frustration, or you're like, oh, glass sucks, or something like that, then come see me, and we'll go over your test. So that's what we're going to try. My biggest thing is please write clearly, please explain your steps, and I will try to make the instructions very clear, and I hope you guys all do really well, because it makes grading so fun. And if you don't, it makes it so hard. Okay, any questions then?
You said something about